Welcome to a fascinating journey into the mysteries of the cosmos. Here in today's video, we are going to talk about an idea. Yes, of course, this is an idea. There is no practical evidence of this topic. Topic is what? Gravitational wave memory. The term memory is there. Gravitational wave, that is known to you, I think. Okay. But here in this video, we are talking about gravitational wave memory. So the memory term is there. That means what is the idea behind this topic or behind this term gravitational wave memory? Idea is that gravitational wave itself creates memory. How this is possible? That is not the matter of discussion in today's lecture, but gravitational waves are able to create memory. That is the idea of the present day scientists or present day physicists. You know, general theory of relativity was discovered in the year 1915, 1915. And special theory of relativity was discovered just 10 years ago to that time, that is 1905. And according to general theory of relativity, Einstein introduced the idea of, Albert Einstein introduced the idea of gravitational waves. Means he considered space-time as a flexible fabric, and the deformation of space-time is possible under the influence of under the influence of massive objects. That doesn't mean that if small objects are there and small objects are not able to deform the space-time, that is not the idea. We talk about only massive objects because sufficient deformation will be there in the case of massive objects. But for small objects also, space-time exists. Okay, means deformation of space-time exists, or deformation occurs in case of small objects also. Anyway, so I was talking about what? Space-time is considered as the flexible fabric, and he, means Einstein, introduced the idea of gravitational wave when in the year 1915, okay, not 50, 1915. But that was there was no practical evidence at that time. Actually, during his lifetime, there was no practical evidence of this gravitational wave. In the year 2015, so there is a gap of 100 years, 1915, and I am right now talking about 2015. By using advanced observatories like LIGO and Virgo, scientists found the existence of gravitational waves. You know, black hole mergers, then collision of neutron stars. So during such a cosmic phenomena, gravitational waves are generated, and those gravitational waves were captured by using those advanced techniques like LIGO and Virgo. So that way gravitational waves were confirmed. Means Einstein's theory of what? General theory of relativity. Okay, that theory was proved to be correct. Means the prediction of gravitational waves, that was proved to be correct. But then in the minds of the scientists, new idea came. Okay, and that idea is what? Gravitational wave memory. That means whenever gravitational waves pass through a space-time, in that case, there is a permanent mark left behind by the gravitational waves. Permanent mark means permanent deformation occurs in the space-time if gravitational waves pass through that space-time. Permanent mark. So since that mark is permanent, so that can be considered as the memory. Whenever some cosmic cataclysms occur, cosmic cataclysms means I was talking about those black hole mergers, then collision of neutron stars. Even the Big Bang itself can be considered as the cosmic cataclysms. Okay, that means those things are very big. Okay, so since those things are very big, so they should generate gravitational waves. And since gravitational waves are acting as the memory, or the space-time itself acting as the memory, that means by analyzing the space-time itself, we can know many things about Big Bang itself, then neutron star collision, then black hole mergers. Okay, just by examining the gravitational wave memory, means by examining the space-time itself. Still there is no practical evidence of this thing. Scientists are trying, means scientists are exploring, they are trying to devise new techniques. They are trying to devise new techniques to capture this gravitational wave memory. Okay. So, not only these things, we will be able to know if it is discovered, if really this memory exists, then in that case, we will be able to know many things about black hole mergers, neutron star collisions, Big Bang, but also there are more things. Reality of the universe could easily be known. Okay, reality of the universe, still it is not known. Okay, we know many things about the universe, but not fully. It is not known. So we will be able to, since it is acting as a memory, gravitational wave memory. Okay. Again, quantum mechanics, quantum gravity, those things are still not fully understood by the scientists. So those things also could be fully understood by the help of this memory, gravitational wave memory. Okay. Again, I want to say the same thing. This is still just an idea of the scientists. Okay. Still there is no practical evidence of this memory known as gravitational wave memory. And when it occurs, I want to repeat the same thing once again here, that whenever gravitational waves pass through space-time, in that case there is a permanent imprint, or there is a permanent mark caused by the gravitational wave. Okay, just like if you imagine you imagine a lake full of water. Okay. And if if you throw a stone, what happens? Waves are formed. And the ripples move outward, right? Or the waves move outward. But after some time, what happens? The water of the lake comes to a still condition again. There is no movement. So you cannot say at that time that if you did not see the event of throwing the stone into the lake, then a new person cannot say that whether the stone was thrown or not, because there is no permanent mark. If you examine the water of the lake, there is no permanent mark whether the stone was thrown or not. But in case of gravitational waves, that is not the case. In case of gravitational waves, if gravitational waves have already passed through a space-time, then there is a permanent deformation caused by that gravitational wave. That means caused by that event for which gravitational waves were generated. Events like black hole mergers, collisions of neutron stars, etc. Okay. Anyway, so this was all about today's topic, gravitational wave memory, a fascinating concept in the realm of physics, in the realm of relativistic mechanics. Anyway, so this was all about today's video, and this is the end of this video. Thank you for watching this video.